Okay, number 1. So we are adding 2 trinomials. So I am going to circle or use different symbols to mark my like terms. So I have negative 5x squared and negative 3x squared. And those added together would be negative 8 squared. 8x squared, I'm sorry. And then I have negative x and negative 5x, which makes negative 6x. And 4 and 2, which makes 6. Number 2, we are multiplying 2 binomials. So we're multiplying actually just, I'm sorry, 2 monomials. So actually my laws of exponents here can apply. So I have 8 times negative 3, which is negative 24. X to the third times x to the second would give me x to the fifth. And y to the second times y to the third would give me y to the fifth. Okay, so also remember we could actually expand these. And since we're only multiplying 2 monomials, then our laws of exponents could apply there. Okay, so number 3. We are subtracting. So I find it helpful when I'm subtracting to bring this down and actually show that I'm subtracting each piece based on like terms. So I'm taking 8x squared. I'm going to rewrite over here. And I'm subtracting negative 8x squared. So if I subtract negative 8x squared, that's going to be like I'm adding 8x squared. So I can go ahead and write that. And then I have negative 3x. And I'm subtracting 5x. And then I just have my negative 5, but I'm subtracting negative 5. So really, let's say I have 0, and I'm taking away negative 5, so it's like I'm adding 5. Okay, so that gives me 16x squared, negative 8x, and then 5. Number 4, Jacob has 9x minus 6 V-Bucks and wants to give some to 3 friends. How many V-Bucks does each person get? Okay, so 9x minus 6, and he has 3 friends. So he really wants to take this and he wants to divide it with 3 friends. Okay, so remember there's multiple ways to divide. If I want to take 9x minus 6 and divide, I could do long division. I prefer my area model. So 9x minus 6 can be written like this. I'm dividing by 3. So this must be 3x, and this must be negative 2. So 3x minus 2. So how did I know to just use one row while I only had a binomial divided by a monomial? So that tells me how many rows to use since I'm dividing by a monomial. I'm only going to have one row, and then I have two columns because it's a binomial. Number 5, Jason has negative 4x plus 4x to the third plus 7 feet of aluminum wire for a project. His teammate has 3x to the third minus 9 minus 3x feet of aluminum wire. How many feet of aluminum wire do they have combined? Okay, so I am going to add because I want to combine them. So I'm going to line up my like terms. So I've rewritten 3x to the third minus 9 minus 3x to line up with the first one. It doesn't really matter how you rewrite them if you're using it to line up your like terms. Just make sure you line up your like terms correctly. Like my 3x to the third is positive. My negative 3x is lined up with negative 4x, and my negative 9 is lined up with 7. Okay, so negative 4 and negative 3 make negative 7x. 4x to the third and 3x to the third make 7x to the third. And negative 9 and 7 make negative 2. And I'm going to rewrite this as 7x to the third minus 7x minus 2. Number 6, 3x squared plus 4x minus 2 divided by x minus 1. Okay, so I am going to use an area model because that's what I prefer. On the next one, I will use long division so you can just see the difference between those. So I'm taking 3x squared plus 4x minus 2. And remember, we don't want to just automatically place our minus 2 here because we could have a remainder or something. So I'm going to go ahead and just do x minus 1. And I know that this then has to be 3x to make 3x squared. And that means this is negative 3x. But I have a trinomial of positive 4x. So this needs to be positive 7x to make positive 4x. So this will be 7 to make 7x. And this will be negative 7. Okay, so I actually do have a remainder. I don't want negative 7. I want negative 2. So my remainder, what would I need to get to negative 2 would be positive 5. I would need to add 5 to get to negative 2. So that means my answer is 3x plus 7 plus 5 over x minus 1. Okay, number 7, 2x squared plus 3x minus 4 divided by x plus 5. So I'm going to use long division this time. So 2x squared plus 3x minus 4 and x plus 5. So remember, we are looking at what would x need to multiply to get 2x squared. So it needs to multiply by 2x. So 2x times x is 2x squared, and 2x times 5 is 10x. Okay, and I'm subtracting this whole thing. So when I subtract, those are gone, and 3 minus 10 is going to give me negative 7x minus 4. Okay, so now what would I need to multiply x by to get negative 7x? So I would need to multiply by negative 7. Negative 7 times x is negative 7x. And negative 7 times 5 is negative 35. And I'm subtracting all of that. So negative 7 minus negative 7 is 0. Negative 4 minus negative 35. If it helps you, go ahead and change this. So it's really like I'm adding 35. Is 31. So I have a remainder. So when I write my answer, I should have 2x minus 7 plus 31 over x plus 5. Okay, number 8. 4x minus 3 times 3x minus 5. So I'm going to distribute, or I can use my area model, but I'm going to distribute my 4x to 3x, which gives me 12x squared, and then my 4x to the negative 5, which gives me negative 20x. And then I'm going to distribute my negative 3 to 3x, so minus 9x, and my negative 3 to negative 5, plus 15. Okay, now I'm going to combine my like terms. So I'll have 12x squared minus 29x plus 15. Okay, so subtract 3x squared minus 8x minus 2 from negative x squared plus x minus 4. Okay, so I want to subtract this from this. So I'm going to go ahead and line these up. Negative 3x squared. And I'm going to do this like I'm adding, so I'm changing all of these. So if I do minus 3x squared minus negative 8x would be like positive 8x. And minus negative 2 would be like plus 2. So now I can just add all of these together. So negative 8x or x squared and negative 3x squared make negative 4x squared. 8x and x make 9x, and negative 4 and 2 make negative 2. So 4x squared plus 9x minus 2. Sorry. What is the area of a square that has a side length of 3x plus 5? Okay, so knowing that it's a square, and I want the area, and all sides are the same, I can actually just do 3x plus 5 squared, which we know we need to rewrite. I can't just distribute the 2. I need to rewrite as 3x plus 5 times 3x plus 5. So using my distributive property, I'll have 9x squared plus 15x plus 15x again, and plus 25. So combining my like terms, I'll have 9x squared plus 30x plus 25. A skyscraper is 3x to the third plus 5x to the second minus 4x plus 6 stories tall. Each story is 5x squared feet. How tall in feet is the skyscraper? Okay, so this is a problem I really had to think about, and I actually went back and I substituted just numbers in. So it helped me read the problem a little bit. A skyscraper is 8 stories tall. Each story is 8 stories isn't very tall, but you know, each story is 7 feet. How tall in feet is the skyscraper? Well, I would know when I read it this way that I would just multiply. So that's what I'm going to do with my polynomials. So I have 3x to the third plus 5x squared minus 4x plus 6 times 5x squared. Okay, so I'm going to distribute my 5x squared. So 5x squared times 3x to the third will give me 15x to the fifth. 5x squared times 5x squared will give me 25 times x to the fourth times negative 4x will give me minus 20x to the third, and times 6 will give me 30x squared. So my final answer is 15x to the fifth plus 25x to the fourth minus 20x to the third plus 30x to the second. Number 12, 20x squared minus 13x plus 2 divided by 5x minus 2. Okay, so I'm going to use the area model to divide. So I'm dividing by 5x minus 2. I know the 20x squared will belong in this box. And then I can start determining what linear factor I'm actually multiplying by to get this. So I have 4x, which makes this negative 8x but I want 13 or negative 13. So I'm going to add a negative 5x here. That would make this have to be negative 1. And negative 1 times negative 2 is positive 2. And I have no remainders. So my answer is 4x minus 1. Okay, quadratic transformations. Describe how the a, h, and k values will transform a quadratic function. So my a value will be either a vertical, if it's greater than 1, will be a vertical stretch. A is greater than 1. If a is less than 1, it'll be a vertical compression. So vertical stretch, remember, means narrower, and vertical compression means wide. Minus h will shift to the right if h is positive. I mean, this is subtracting. So if I put in like a 2, so if h is positive, but if I put in a negative h, which would make me add, then it's going to shift to the left. And k is going to, if k is positive, it's going to shift up. If k is negative, it's going to shift down. course, you can always graph them in your graphing calculators and see how they did change. Okay, number 2, describe the transformation in words, then circle the correct equation. Okay, so compared to my parent function begins here. So I can see that it shifted to the right 1, 2, 3 times. Okay. And I can see that it went down 1, 2, 3, 4 times. Okay, so I realize that now that I'm looking at this problem, that there's some answers and we don't really know how to determine this value and this value. We talked briefly that you could count this way to determine your A value, but that's not something that you're actually expected to be able to do. So really, technically, you would be given your parent function here to tell if it's wider or if it's narrower. So I'm not going to worry about if you know that. So just make sure that you understand that you know that your options would need to be B or D. Don't worry about these A values and which one those would be. The question will be more clear so that you can determine that. Okay, so number 3, describe the transformation in words, then circle the correct equation. So from what you can see, if there's been a reflection, so it's either F or G, and it's shifted to the left 1, so my answer has to be G. The equation for the function is negative 3x squared plus 4. Describe the transformation in words. So we can see there's been a reflection. There's been a vertical stretch. And again, you could graph this function as well as your f of x equals x squared function in your calculator. And you could see these things. And then plus 4 is going to be shift up 4. The function f of x equals x squared, is shown below. Describe the transformation in words for the function y equals 1/4 f of x. Okay, so if I take my parent function and I multiply my parent function by 1/4, what will that do? I can actually type that into my calculator, but when I type it in, I need to write it in as 1/4 x squared. Again, you can see it's outside my parentheses, so it's something vertical. And if it is less than 1, that means it's a vertical compression. Okay, number 6, the graph below represents the parent function f of x equals x squared. Which graph best illustrates the graph of the equation y equals a f of x plus d if a is negative 1/4? So I'm going to rewrite this, y equals negative 1/4 It says that f of x is x squared. So I'm going to replace my f of x here with x squared. So negative 1/4 x squared plus, oh, and it says d is 3. So I'm going to fix that. D is 3. So plus 3. Okay, so I'm going to have a reflection. So that's going to narrow down my choices. So it's not C or D because I need a reflection. And I'm going to shift up 3. Okay, and both A and B are shifted up 3. And I'm going to have a compression, a vertical compression, meaning it's going to push down vertically or push towards the x-axis. So if I imagine which one of these I'm pushing towards my x-axis, we should choose A because it has become wider.